All right, last page of the study guide is a throwback to some stuff that we've done in the last 2 units. So problem number 18 asks you to write out the full trig chart. You have done that repeatedly for me. All right, so let's get the full trig chart going here. We have sine, we have cosine, we have tangent. We're going to have 30 degrees, which is pi over 6. Let me actually write that. Something that I can actually read. There we go. We have 45 degrees, which is pi over 4. And last but not least, we have 60 degrees, which is pi over 3. All right, so in the actual trig chart, we've got 1/2 root 2 over 2, root 3 over 2. Reverse it, 1/2 root 2 over 2, root 3 over 2. Tangent, root 3 over 3, 1, and then root 3. Now, I always have to put the additional information. So I'm going to have my little ASTC. And my reminders, that is 0 or 2 pi, and it is the ordered pair 1, 0. This is pi over 2, which is the ordered pair 0, 1. This is pi. It is the ordered pair -1, 0. I can read that, okay. And then this is 3 pi over 2, which is the ordered pair 0, -1. All right, so all this information is what I'm going to use to now answer the rest of these questions. So for everything after this, it says simplify the following. It says write exact answers only. These problems, you are not going to be able to just type them in your calculator and say, oop, the answer is 0.7 something, something, something. I don't want those answers. I'm going to be looking for things like root 3 over 2, root 2 over 2, things like that are exact. And I'm also going to be looking at your work. All right. So first things first, problem number 19, I need to figure out where 4 pi over 3 is. Well, 3 over 3 would be pi. 4 pi over 3 is going to be into the third quadrant, which is so we rotated here, AST. So tangent's positive, which is going to make sine negative. The reference angle here, your theta prime, is pi over 3. So in the trig chart, I want to grab the sine of pi over 3. Now, I have a separate trig chart off to the side, and that's going to help me out so I'm not constantly bouncing back and forth because I don't want to keep zooming in and out. So sine of pi over 3 is root 3 over 2. So because it's in the third quadrant, it's going to be negative root 3 over 2. All right, so tangent of negative pi over 4. So remember, if your radian measure is negative, you're going to be rotating clockwise. And pi over 4 would be right here. There's your rotation. So AST, that's the C, which is going to make this tangent negative. Your reference angle, so theta prime, is going to be pi over 4. So tangent of pi over 4 is 1. And when we multiply these together, a negative times a negative is positive. Root 3 over 2 times 1 is going to be root 3 over 2. So that's the exact answer. You technically could check it with your calculator, make sure you're in radian mode, and you would make sure that whatever decimal answer you get when you multiply these together would be equivalent to whatever root 3 over 2 is in your calculator. The problem is, it's just, your calculator isn't going to be able to tell you the root 3 over 2, I don't think. All right, so I'm going to slide over to number 20 and do the exact same thing. So I've got pi. So if I think about where pi is on my unit circle, pi is sitting right here on the x-axis. That is the ordered pair -1, 0. Now, secant is the reciprocal to cosine. And remember, your ordered pairs are cosine sine. So the cosine value is -1. The reciprocal to -1 is still -1. Okay, so grab the cosine value, did its reciprocal for secant. All right, 13 pi over 6. So 13 pi over 6 is actually a full rotation. There's 12 pi over 6. That would be 2 pi. And now I got to go a little bit more. So I'm into quadrant 1, which is all. So that means my tangent value is going to be positive. And my theta prime, my reference angle, is pi over 6. So I want to know the tangent of pi over 6. So that's going to be root 3 over 3. When I multiply -1 times root 3 over 3, I'm going to negative root 3 over 3. All right, exact value. And I'm just going to keep going on through the rest of these. I got a few more. All right, so let's see. Cosine of negative 3 pi over 4. Yep, read the right thing. So negative means I'm going to rotate clockwise. 3 pi over 4 is going to rotate me into the third quadrant. All right, so rotate, rotate, rotate. I'm going to be down here. So yes, t, right? So tangent's going to be positive, but that means that my cosine is going to be negative. My reference angle is going to be pi over 4. So the cosine of pi over 4 is going to be root 2 over 2. All right, so now I've got the secant of 225 degrees. Now, 225 degrees is more than 180, right, which is pi, and less than 270, which is the 3 pi over 2 here. So that's going to rotate me into, again, third quadrant. So that means that secant is going to be negative because tangent's what's positive down here. And I got to figure out my reference angle here. So how far am I away from the x-axis? Well, for my reference angle, I'm going to take the angle measure, so 225 minus 180, and that's going to give me a reference angle of 45 degrees. So secant of 45 means I've got to find the cosine of 45 and do its reciprocal. So the cosine of 45 degrees is root 2 over 2, so the reciprocal would be 2 over root 2. Now there's a method to my madness. I did not rationalize that because I looked at what I was dealing with here, and if I recognize the root 2 here and the root 2 here will cancel, 2 and 2 will cancel, and negative times negative is a positive, so this whole mess just turns into 1. Now, in a different problem, you might need to rationalize this. You'd need to see what's going on, okay? So 21 is done. I'm going to slide on over to number 22 and keep doing the same thing. All right. Now, 17 pi over 3 is going to be a lot of rotations that I'm not sure I want to deal with. So off to the side here, I'm going to take 17 pi over 3, and I'm going to start subtracting 2 pi off of it. Now, I have a calculator handy, so let's see what I get here. 17 over 3 minus 2 gets me 11 pi over 3. And I'm going to subtract another 2 pi. That's going to get me 5 pi over 3. I like that a lot better because I know where 5 pi over 3 is on the unit circle. So what I've just done, if you remember from last unit, we had coterminal angles. And coterminal angles, you can find them by adding or subtracting 2 pi. So instead of doing a whole bunch of rotations here with 17 pi over 3, I just subtracted off a full rotation until I found a value that was on the actual unit circle. So 5 pi over 3 is all the way rotated down into quadrant 4. So this is C. Now, you got to be careful because you might look at this and say, oh, C, and this starts with a C. But the problem is this is cosine, and cosecant is the reciprocal to sine. So in the fourth quadrant, sine is negative, which also means cosecant is going to be negative. All right, so theta prime is pi over 3. The sine of pi over 3 is root 3 over 2. So if I do the reciprocal now, that's going to be 2 over root 3. Okay, so that part's taken care of. Now I'm going to deal with cotangent. So cotangent here, now I've got negative 9 pi over 2. And again, I'm not sure, there are going to be a lot of rotations here that I'm not sure I want to deal with. So if I take, where can I work here? I got some space over here. So negative 9 pi over 2, and I add 2 pi. Let's see what happens when I do that. So negative 9 over 2 plus 2 is going to be negative 5 pi over 2. Let's add another 2 pi to that. I get negative 1 pi over 2. Now that I can deal with. I know it's still not on the unit circle because the unit circle is from 0 to 2 pi. It's positive, but I can deal with this as a single rotation with a negative because pi over 2 would rotate up to the y-axis. So negative pi over 2 is going to rotate down. It's going to be this point right here, which is 0, negative 1. Now, cotangent is cosine divided by sine. So cosine divided by sine, 0 divided by negative 1, well, your cotangent value here is going to be 0. All right, now the fun part is I don't need to worry about rationalizing this expression that I got for cosecant, because it doesn't matter what this is, times 0, and my whole answer is going to be 0 here. Okay. So if you need to use coterminal angles, absolutely use those coterminal angles, or you just need to keep counting out the rotations. All right, 2 more problems. All right, so problem number 23, everything is in degrees here, but clearly negative 1035 degrees is, I don't know where that is on my unit circle. So I'm going to grab my calculator. I'm going to add 360 this time. So plus 360, and I get negative 675. I'm going to add another 360. Again, just using my coterminal angles. So that got me negative 315. If I add another 360, hey, look, I've got a 45-degree angle. And all of these are in degrees. So 45 degrees means I am sitting right in quadrant number 1. That's everything is positive, and my reference angle is 45 degrees. So the sine of 45 degrees is going to be root 2 over 2. Now I want to do the same thing in this case for tangent of 420. So where is 420? I'm not exactly sure, but I can take 420 degrees and I can subtract 360, always using a full rotation. And that's going to be a 60-degree angle, which is still in quadrant 1, so everything is positive. My reference angle is going to be 60 degrees. So what I'm looking for now is the tangent of 60 degrees, and that is root 3. Now, I don't need to rationalize anything, but I do need to multiply. Now, if you need it, that would be over 1. You're going to multiply numerator to numerator. Root 2 times root 3 is root 6. Denominator times denominator, 2 times 1 is over 2. No, you cannot divide these. Your answer is just going to be root 6 over 2. All right, so let that be. Number 23 is done. Again, using coterminal angles as needed. In this case, we were in degrees. All right. Last but not least is problem number 24, and then I am done with this study guide. So let's talk about where 900 degrees is. Well, actually, no, I'm not going to talk about where 900 degrees is. I'm going to figure out what it's coterminal to. So 900 minus 360 is 540 degrees. If I subtract another 360, that's going to be 180 degrees, which right here, that point is negative 1, 0. Now, cosecant is the reciprocal to sine. Sine is 0. The reciprocal of 0 is one of my favorites, undefined. All right. Now, technically, I know my answer already because undefined times anything is going to be undefined. However, I'm going to tell you right now, if you were to stop here, I'd be looking for this part of the problem. All right. So make sure you show your steps, even to figure out what this side is. So let's figure out what the sine of negative 4 pi over 3 is. So negative 4 pi over 3, this one I can keep track of. So I'm going to rotate clockwise. If I rotate from the x-axis to x-axis, that's pi, but I need to go a little bit more. So 4 pi over 3, but negative, rotates this way. So AS, oh cool. So sine's positive here. That's good. So positive, my reference angle theta prime here is going to be pi over 3. The sine of pi over 3 is root 3 over 2. And again, I told you already, I knew the answer was going to be undefined because you have undefined times some value, it's still going to be undefined. All right, so this is a little throwback to some stuff that we did last unit. It is part of your test along with the graphing and writing equations. So as always, please make sure if you have any questions, you reach out to me and let me know what you are struggling with.